Hello everyone, welcome to my channel, The Logic of Everything. The purpose of this channel is to start the thinking process on how things actually work. Through my videos, I'll explain first some basic concepts, gradually progressing into difficult ones. The plus point of this channel is that I am a student myself and I know the type of silly mistakes kids my age do. And hence, I request you to subscribe to this channel because there are a lot of other videos of maths, physics, chemistry coming up. So today we'll be starting with maths. The thing I like most about maths is algebraic identities. You must be familiar with the algebraic identity a plus b plus c whole bracket square is equal to a square plus b square plus c square plus 2 times ab plus bc plus ac. Now, most of you will not have studied the applications. So I'll give you a question right now. If a plus b plus c is equal to 0, then prove that 1 upon a plus 1 upon b plus 1 upon c whole bracket square is equal to 1 upon a square plus 1 upon b square plus 1 upon c square. I'll explain you this sum. So if you really want to try, you can pause the video. Now, according to this algebraic identity, the expansion of the left hand side will be 1 upon a square plus 1 upon b square plus 1 upon c square plus 2 times 1 upon ab plus 1 upon bc plus 1 upon ac. So basically this is this thing, the 2 times 1 upon AB plus 1 upon BC plus 1 upon AC is extra. And in the RHS, I just want to prove that this. So if by some method I am able to prove that this is equal to 0, then I'll be able to solve the sum. So how will I go about it? The first step will be try to find the LCM and then add all these fractions. So the LCM will be a, b, c, and then this is going to be a plus b plus c. I hope you'll take the clue. It's already given that a plus b plus c is equal to 0, and hence this is equal to 0. Then this fraction 0 upon abc will also be equal to 0, and hence this box is equal to 0. The application was so easy, but I think most of you stumbled upon this step. So now we can write that LHS is equal to 1 upon a square plus 1 upon b square plus 1 upon c square, which is equal to the RHS, and hence this is proved. So this is a question, but you have to remember it for applications further. One of the applications that I really love about this identity we just learned about, that if a plus b plus c is equal to 0, then this happens, is in the next sum. Actually, I'll write the sum. 1 plus 1 plus 1 upon 4 So this is an application of the identity that I just taught, and this was a question which was asked in KVPY. So this is actually a really easy sum. So please pause the video and I request you to solve this sum. Okay, now I think I'll start. So there is some pattern that you must have observed by now. That is, this is 1 and this is 1 square plus 1 upon 2 square. Then this is again 1 and this is 1 upon 2 square plus 1 upon 3 square. Again this is 1 upon 3 square plus 1 upon 4 square. And this continues until 1 plus 1 upon 20 square plus 1 upon 21 square. So the shortest form in which I can write this entire statement is sigma n is equal to 1 goes on to 20 root of 1 plus 1 upon n square plus 1 upon n plus 1 square. Now the first time I tried to solve this problem, I did this. But then I understood that this is application of this. And for this, I need to prove that a plus b plus c is equal to 0. So in which way can I prove that these denominators, 1 n square and n plus 1 square, the addition is equal to 0? There is only one way. So there is a different way in which you can frame this. This goes here and then this will be 1 upon 1 square plus 1 upon n square plus 1 upon minus of n plus 1 whole bracket square. Now as you can observe, minus of n plus 1 and n plus 1, the roots, the addition is 0. Now what can I observe here if I keep this a, this b and this c? A plus b plus c, which is 1 plus n plus minus of n plus 1 is equal to 0. The same thing, right? So now I can apply 1 plus a square plus 1 upon b square plus 1 upon c square. As we have learned before, this 1 upon a square plus 1 upon b square plus 1 upon c square is equal to 1 upon a plus 1 upon b plus 1 upon c whole bracket square. And hence I can write this as 1 upon 1 plus 1 upon n minus 1 upon n plus 1 whole bracket square. Now this square and this square root will be cancelled, and hence I can write it as n goes from 1 to 20, 1 plus 1 upon n minus 1 upon n plus 1. Now what will be the long form of this statement? Now sigma is basically addition, repeated addition. So if I have to write the full form of this statement till 20, I will go like 1 plus 1 minus 1 upon 2 plus 1 plus 1 upon 2 minus 1 upon 3. Then it will be plus 1 upon 3 minus 1 upon 4, and this will go to 1 plus 1 upon 20 minus 1 upon 21. Now this is a fairly easy sum. You can see that minus 1 upon 2 plus 1 upon 2 will be cancelled. Minus 1 upon 3 minus 1 upon 3. Similar way, minus 1 upon 4 will be cancelled with the plus 1 upon 4 that I didn't write. And similarly until this. Until 1 upon 20, every term will be cancelled. So what are we left with? These ones. Now this 1 will occur 20 times. So we'll write that as 20. Plus there is an extra 1 here, 1 minus 1 upon 21, which is left here. And this answer is 440 upon 21. Now this was a very easy sum. and it had been asked in KVPY, which is a very important exam. It was so easy. I mean, the simple application was this algebraic identity. Now, that is the fun of maths that I started understanding a few weeks ago. It's so easy and it's so logical. So the best way I tell you to do practice this is to think about questions. Thank you. If you do like the video, please comment, please ask doubts, please like the video, subscribe and share.